Hello friends, in today's lecture we will see state variable models and what are the different types. We also see the properties of state variable transition matrix. Then we will talk about controllability, observability. What are the definitions, functions of controllability and observability, and based on that we have some examples. So based on that we will solve some problems today. So the very first topic is properties of state transition matrix. So as you can see, there are 5 properties where phi of 0 is equal to 1. That means if we substitute t equal to 0, so e raised to a, which is a constant, that is a into 0, so e raised to 0 is always a 1. So that is the first property. So similarly we have phi of t is equal to phi of minus t the whole raised to minus 1. That means it is an inverse property like a mathematical property. So similarly we have the different state transition matrix. So using this matrix, using these properties, we will solve some problems. So let's see the first problem as it is given. A question is, a feedback signal is having the closed loop transfer function. Construct a state model for the system. So here is the transfer function, which is nothing but y of s divided by v of s, which is equal to 3s plus 4 divided by s square plus 5s plus 6. So this is what the transfer function given. You have to construct a state model. So just see the steps. So the very first step is we can split our given transfer function in this form, where x1 of s divided by v1 of s will be 1 upon s square plus 5s plus 6, and the second one, y of s divided by x1 of s, will be the numerator term, that is 3s plus 4. So the first term is given as a equation number 1, and this is the second term given as a equation number 2. So from the equation number 2 we just cross multiply. So on the right hand side we get v of s equal to x1 of s square plus 5s plus 6. So just multiply with this, you will get s square into x1 of s plus 5s x1 of s plus 6 x1 of s equal to v of s. So this is just simplification. Now you have to take the Laplace inverse. So taking a Laplace inverse to this equation, this is the x square term, so we will get the second derivative of x1 of t. This is the s term, so the first derivative of x1 of s, that is x1 of t, the coefficient is 5, plus x1 of s is nothing but directly x1 of t. v1 of s can be written as u of t. Alright, so this is the equation we get after taking a Laplace inverse. Now we can write the double derivative as x1 of double dot, that means a double derivative. x1 of dot means single derivative, and x1 of t directly written as 6x of t equal to u of t. So that is given as equation number 3. So in the next slide, let x1 of dash or 1 dot, that is the first derivative, can be written as x2 of t, and then x2 of dot t can be written as x3 of t. So in this equation number 3 we substitute these values. So after substituting these values in equation number 3, so this is the equation number 3. So look at once again, this is the equation number 3. So by substituting these values, x1 of dot 1, x2 dot t, you will get x3 of t plus 5 x2 of t plus 6 x1 of t equal to u of t. So this is given as a equation number 4. Now equation 4 can be written as 0 x dot raised to 3 plus x3 of t plus 5 x2 of 3. Why it is written as 0? Because here in this equation x3 dot term is absent, that is why it is written as a 0. So we keep this term on the left hand side, we take this terms x3, x2 and x on the right hand side. So we got this equation. Now to find out the state space model, we write this is in a matrix form. So here x1 dot of t, x2 of dot of t, x3 dot of 3 equal to, now you will write x1 dot of t. So what is x1 dot of t? That is x2 term. So here x2 term is present, x3 and x1 term are missing. So 0, 1, 0. So from this equation x1 dot of t, we get x2 of t only. So that is second term is present, first and the last term is absent. So that is x1 of t. Now the second x2 dot of t. So x2 dot of t is nothing but x3 of t. So x3 of t is nothing but the third term. So first two terms are not there in this equation. So we write 0, 0, 1. Similarly, we have x3 dot of t. So what is x3 dot of t? That is nothing but, we can write it as x3 dot of 3 is minus 6, which is x of t, minus 5, which is x2 of t, and minus 1, which is x3 of t, into x1 of t, x2 of t, x3 of t plus u of t. So since u of t is the last term, the first two terms are missing, so that is 0, 0, 1. So this gives as equation number 5. We have given this equation as equation number 5. Now using equation number 2. So what is equation number 2 basically? So equation number 2 is this. So what you will do is, you will multiply denominator with 3s or plus 4. So we multiply this term x1 of s with this. So on the left hand side, y of s is remain, which is equal to 3s plus 4 into x1 of s. So these are just simple mathematics. You just try to see the steps, which is very simple. You just need to remember the formula. The formula is this. You have to write them in a matrix form. Simple. So after evaluating or solving that equation, we got this. We have to again take a Laplace inverse of this, because we have taken the Laplace inverse of x term. Now this is a y term. So y of t is nothing but 3. Now since it is s term, so d by d, this is x1 of s, so directly we will write 4 into x1 of t, right? Now therefore 3 x1 of dot. Similarly we have done for x1 of t. So this is therefore 3 x1 dot of t plus 4 x1 of t equal to y of t. Let x1 is equal to x2. Therefore 3x2 is plus 4x1 is equal to y of t. So we have written x2 of t in place of x1 of dot t. This gives us the equation number 6. Now the output can be written as y of t is equal to, now here x1 of t, the coefficient of x1 is 4, coefficient of x2 is 3, x3 term is missing, so directly that is 0, x1, x2, x3. So this is equation number 7 and the equation number 5. This is the equation number 5. Alright, and this is the equation number 7. This is what exactly the state variable model. This is what exactly the state variable model. Now the question comes again, why we have evaluated this state variable. Okay, so just try to understand the concept, because we have already studied what are the methods of controller, PID controller. Okay, to formulate a state variable model of a system, the basic definition is that system state and its minimal set of variables is required. So as compared to transfer function, the state variable approach gives us the timely behavior of internal variable of model. So these variables help us to determine the behavior of a signal in any internal part of the system. Therefore the output variable of the system can also be determined. So in this is the output variable of the system, which gives you the time behavior, because of which we can easily find out the system's behavior or stability. So this is the another method. Alright, now question number 2. So this is the second question. You can see here it is given as, from the given state space model obtain the transfer function. In the earlier question the transfer function was given, we had to calculate the state variable. Here the transfer function is not given, state space model is given, which is nothing but matrix A, matrix determinants A, determinants B, matrix A, matrix B, C and D, and the values are shown. You have to find out the transfer function. So how to find out the transfer function? So we'll see that. So first, the formula to find out the transfer function is C, the square bracket, S into I is the identity matrix, minus A, the whole inverse, into B plus D. So this is the formula. You just need to remember the formula to solve this, where we have to calculate the transfer function and the state space model is given. So you just remember this formula. So here I is nothing but an identity matrix. Since A and B are, A is a 2 into 2 matrix, so we can assume identity matrix is of 2 into 2. Multiply with S into I. So S is a constant, so if you multiply identity with S, so you will get S0 0S. Okay, matrix. Now in the formula we have Si minus A. So we got Si, we subtract with A, so which is A, minus 5 minus 6 1 0, which is given in the question. So this is Si minus of this A. So we got this after subtracting two matrix. Alright, so this is nothing but Si minus A. Now we have to find out the inverse. Now again, to take the inverse, just to need to remember how to take the inverse. So taking the inverse, adjacent of Si minus A divided by determinants of Si minus A. So to calculate determinants, we know very well this multiplied by this minus this multiplied by this. This is how we can get the value of determinants Si minus A. But how to calculate adjacent of Si minus A? So this is Si minus A. So for calculating adjacent, your this term will here S and this term will go here, and instead of 6 it will minus 6, and instead of minus 1 it will be plus 1. This is just how we can calculate the adjacent of Si minus A. And determinants, as I told you, this into this minus this into this. So we got this after calculating the determinants. Now we will substitute these two values in this. So you will get Si minus A the inverse. So this is the Si minus A the inverse. Adjacents of Si minus A, determinants of Si minus A. Now C is 1 1, which is given in the question itself. Multiply with C. So this will be multiplied with C. So 1 by 1 ka matrix is given. Alright. So here this is nothing but Si minus A the whole inverse. You will multiply this with this, so you will get this. So how to calculate this? So this into 1 is this, this into the 1 is this. So this into 1 is this, plus this into 1 is this, this is. Then second term, 1 into this is the term, 1 into this is the sum. So whenever you are multiplying the two, there will be addition. So this plus this or this plus this will be the matrix. Now if you see this, the denominator is same, so can we write it as S plus 1 directly, because the denominator term is same. So S plus 1 divided by S square plus 5S plus 6. Here also the denominator term is same, but here if you see S plus 5 minus 6 will be minus 1, so S minus 1 directly. Now transfer function, the total formula for transfer function is C into Si minus A the whole inverse. So which is already calculated. Now it is B. So in the question B is given with it 1 0. So you multiply with this, you will get the answer S plus 1 the divided by S square plus 5S plus 6. So such type of questions can be asked in the exam. So this is also important for your theory point of view, because 10 marks question can be asked on this. Either they will give you the state transition matrix and they will ask you to find out the transfer function, like in this question. And in the earlier question we have seen that transfer function was given, we had to calculate the state space model. So these two type of questions can be asked. And what is the importance of these two questions is to calculate the time behavior, so that we can comment on the stability. Now the very important topic is controllability and observability. Just try to understand what is controllability. So in control system there are many systems that need to be controlled. So it is also necessary to find an optimum solution for the control system problem. Hence, the task of a control engineer is to design systems using controller and compensator. So in the previous lecture we have already studied controller and compensator units to interact with these already existing subsystems. So we might encounter certain system that cannot be controlled. The concept of controllability refers to ability of a controller to arbitrarily alter the functionality of the system plant. Controllability implies the ability to change the state by input. So this is what the function and the definition of controllability, which is used to find out the solution of a various functionality of the problems. That is why it is called as a controllability. How many functions it can be controlled. And we have the observability. We have seen that the state variable of a system X represent the internal working of the system. This can be separate from the regular input-output relation. Now if you define observability, the internal state variable of the system can be externally measured. Observability implies the ability to measure state by making measurements at output. So observability is nothing but ability to measure the state by making measurements at the output side. So that is what the definition and the function of observability, whereas the controllability is related to the input, whereas the observability is nothing but to apply some measurement at the output side. So these are the two terms, very important, and based on this the problems can be asked in the exam. So we'll take another example based on the controllability and the observability. Now the question is, a linear time invariant system is characterized by the state variable model. Comment on the controllability and the observability. As you can see, this is the state space is given, time invariant model. So x1 dot x2 dot is equal to -1 0 0 -2 x1 x2 plus 0 1 u of t, whereas y of t is given as 1 2 into x1 of 2 x2. Alright, so this is given in the question itself. Let's try to find out the controllability. So how to find out the controllability? The very first step is we shall check the order of the linear time invariant system. Now how to find out the order? So we know that x dot of t is equal to ax of t plus b u of t. So we can compare this equation with this given equation. So you will come to know that if you are comparing, so your a will be -1 0 or 0 -2. Alright, and your b will be 0 1. Alright, here a is n into n matrix. Here where a is the n into n matrix, so in this case the a will be 2 into 2 matrix, because you are comparing this equation with this. So the value of matrix is 2 into 2 by 2. Alright, the necessary and sufficient condition for controllability is the rank of the matrix, that is nothing but n. So n is the size of the matrix. How to calculate the n? So a n q c is equal to b a b a square b a raised to n minus 1 into b. Comparing equation with the given example, so we in the previous slide we have seen we compare this with this. So after comparing we can say that a is this and b is this, where a is 2 into 2 matrix. Now here is the formula. This is the actual formula where we have ab. So we will find out AB first. AB will be nothing but 0 -2 after multiplying these two matrices. Alright, what is QC? QC is nothing but BAB. So BAB, what is B? 0 1, or what is AB? 0 -2. Now we calculate the determinants of QC. We have to calculate the determinants of QC. So how to calculate the determinants? 0 into -2 minus into 0 into 1. So obviously there are two zeros, so our answer will be 0. That is determinant QC is 0, hence the rank of the QC is 1. Rank of QC is 1, but n equal to 2, since rank of QC is not equal to n. So rank here is nothing but 1. What is rank? That is nothing but a QC, determinants of QC, that is 1, and n equal to, that is nothing but 2 by 2 ka matrix is 2, which is not equal to QC. Therefore the system is not controllable. So to get the system controllable system, we should have QC equal to n. So suppose QC is 2 and n is 2, both are equal, then it is controllable. But in this case you see that QC is 1 after taking a determinants, and n is equal to 2. So here it is not equal, therefore it is not controllable. So this is what we can comment on the controllability. Let's see, we shall now evaluate the observability, because in the second part of the question they have asked you to find out the observability of the system. So to find out the observability of the system, nth order multiple inputs of LTI system can be represented as x dot of t is equal to a x of t plus b of t, this is we know that, and y of t is equal to c x of t. So here in the question if you observe, c is nothing but 1 2, y of t is equal to c into x1 of t. So c is nothing but 1 2. Alright, a system is completely observable if and only if the rank of the composite matrix Q0 is n. Q0 is observability. If it is n, then only it is observable, otherwise it is not, it will be not. So to find out observability, we have this formula, C transpose AT transpose into C transpose. Okay, in this case order of the system is 2 because n equal to 2. In our example, A is, we know the A, we know the C, so we take the A transpose, so the row will become column and the column will become row. So this is how we find out the transpose. Now A transpose T into C transpose T equal to this, we will multiply by this. So after multiplying these two determinants we got this. Now we know the Q, that is observability, that is CT or AT into CT. So this is nothing but CT and this is AT or CT transpose. Alright, now we calculate the determinants of Q0. So after finding out the determinants of Q0, that is 1 into minus 4 minus into minus 1 into 2, that is nothing but a minus 2, which is a non-zero term. One of the property of determinant states that the determinant of n into n matrix is non-zero if and only if its rank is n. Alright, so that is the determinant of QC is non-zero, hence the rank of the Q0 is nothing but 2. Since rank of Q0 equal to n, because we know the value of n is 2, here the rank is also 2, here the rank is also 2, hence the system is completely observable, hence the system is. So this is how we check the system observability. This is the actual formula, you should remember, and after this you have to take the determinants of this. If Q matches equal with n, then it is observable, if it is not, then it is not. Similarly controllability. So this type of questions also can be asked. Now second example, where a time linear invariant system is given, comment on the controllability. Okay, so this is a similar question which can just go through. This is the formula to check the controllability. So after solving these steps, if you see your determinants is 0, so one of the property you know of determinants, that if it is non-zero, that means the rank of the Q0 is n, the determinants of Q0 is non-zero, 0 here, therefore the rank of QC is not equal to n, therefore the system is not controllable. So this is a similar example how to check the controllability and the observability. Okay, so just remember the formula. Alright, just remember the formula. So in this lecture we have studied what is the state space analysis model, what are the properties, okay, and based on that we have seen the problem. If the transfer function is given, how to find out the state space model, and if the state space model is given, how to find out the transfer function. And in the second part we have seen what is controllability and observability, and how to check the controllability of a system and the observability of the system. So that's it. So this is very important questions. just go through that. If you have any doubt, you can contact me, because I'll be uploading this on YouTube, so you directly get the links. Okay, there my detailed contacts is given, so just you can contact me if any emergency or if you have any doubt. All right, thank you very much, all the best.